Hello, let's continue our Sudoku adventure with Bobble by Sanabas. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have counting circles in the grid. The way these work is if a digit appears in a circle, it must appear that many times in the circles. So if a 2 appears in a circle somewhere, then there must be exactly 2 2s in the circles. So it can't be alone, and we can't have, say, three 2s. That wouldn't be allowed. So we could have 2 2s, and then we could have like a 3, and a 3, and then a 1. I don't know. I'm not going to try to solve this right now. But that is how counting circles work. And then we also have Renban lines in the grid. So Renban lines have a set of consecutive digits in any order. So think about 3 consecutive digits for a 3-length line. So maybe 2, 3, 4. And then we could do any order, but as long as the digits it contains, when you sort them, are a string of consecutive digits without repeats, then you're golden. That's a Renban. So we cannot do 2, 3, 5 because there's a gap between the 3 and the 5, or not a run of consecutive digits. All right, that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, there's a little bit of a thing to think about with counting circles. It's often an important thing to consider, which is that the sum of the unique digits in the counting circles is equal to the number of counting circles. That's because if a 2 appears, it uses up 2 of the circles. So if a 2 is in there, then there are 2 circles using it. If a 3 is in there, then there are 3 circles using it. And so ultimately, the digits that are unique need to add to the number of circles. So we can count the circles. We have 1, 2, 3, 4, 5, 6, 7. So we have 7 circles. Now, often the key is to see how many minimum unique digits do we need in the circles. And we can see that this column has 3 circles in it. So we need a minimum of 3 digits in the circles. Now, it has to be 3 distinct digits, and they have to add to 7. And so the only way that works is 1, 2, 4, because that's just in 3 digits, 3 unique digits. That's the only way to get to 7. One way you might think about that, if you're trying to do the mental math here or trying to make it easier on yourself, 1 plus 2 plus 3 would be the absolute minimum for 3 digits, and that's 6. So we have to add 1 to one of these. But in order to not repeat, the only digit we can add 1 to is the 3, and we end up with 1, 2, 4. All right. And so that means that these are actually all from 2, 4. The 1 is in this column, and there's only 1 of them. And so the rest are 2, 4s. Now, I notice there's a 2, 4 pair in this box, and there's also a 2, 4 pair in this column. Now, the 2 can only appear one more time. It's in this triple here. And so what that's telling me is this has to be the 2. Because even if we try to make this 2 and 4, this would also be 2. So this has to be our 2. The 2 is in here, and then the remaining 3 of here are 4s in order to get all of our 4s, and that places the 4 here. All right, so these counting circles gave us a bunch of seed digits, which is nice. Now it should be Sudoku and Renban. How do we want to approach this? So these 4s all look in, placing a 4 here. So this has to be consecutive with the 4 because of the Renban, so it's 3 or 5. How about the 4s looking into this box? That puts a 4 here. So with a 4, we can't have a 1. It's too far away. But we could do 2, 3, 4. We could do 3, 4, 5. We could do 4, 5, 6. So I'm not sure. Just not 1 is what we learned here. Did we place all the 4s? We placed all the 4s. 2 is one of these 2, or one of these 3 actually. 5 is in one of these 2. Okay, so we've placed all the 4s, which means this Renban cannot have a 4 on it because it doesn't. We've placed them all. And so it can't be 4. It can't be a 4, 5, or 6 on it. It must be 1, 2, 3 in order to avoid the 4. And so this is a 1, 2, 3 triple, which is something to remember. They're distinct digits. So for example, this cell here sees the entire 1, 2, 3 triple. So it can't be 1, 2, or 3. And so it must be the 6. It can't be 4 or 5 either. And that means this is a 1 or a 3. Now, if you think about it, this digit here, whatever it is is going to end up in this box somewhere, and it can't repeat in the column or on the ren band, and it's not 4 or 5. And so it actually ends up here. And so this can't actually be a 2, or to remove 2 from the box. So this is not a 2. These two are the same digit. What else can I say about this? I need a 6 somewhere. So this is 2, 3, 6, because we know it's not 1. Remember I said that. I'm not sure what to do with that. If this is 6, this is 5. That seems okay. All right, what else can we do? Does it have to do with this? 1, 2, 3. Okay, let's look at this column. This column needs 1, 3, 6. Doesn't seem immediately helpful. We need a 1, 2, 3 here for the row. Oh, but we have a 1, 2 pair here. So this is 3. That makes this 1, then that 1. Remember, they're the same digit. So this now can only be 2, because it can't be the 1 or the 3. Right, we finished the row with the 2. Finish the ren band with the 3. Or the box if you prefer. This is now a 3, 6 pair. All right, that seemed important. That's not a 3 anymore. In fact, we're down to 1, 2, 6 here. All right, so if this was a 2, this would have to be a 3. If this was a 6, this would have to be a 5. So those are our options for our ren band. This column needs a 5, 6 pair. This column needs a what am I missing? 2, 5. Oh, the 2 can't go here. So this is our 2. This is our 5. And that gives us the 3 and the 6 and the 6 here. Gives us the 3 here and the 5. All right, that seems important. This is our 1, giving us 2 and 1 here. Finally finishing our circles. That's not a 1. Still can't resolve this. What's left in this box, though? We need a 1, 3, 5. This can't be 1. So the 1 goes here. And this is the 3, 5, but it's not the 5. So that's 3 and that's 5. So now this can't be 2 because this didn't end up 3. So this is 6 for it to be 4, 5, 6 on the red band. This is 2. And we should be able to just finish up here. 5 and 6 here. Down here I need 2 and 6. They go like this. And then up here I need 1 and 3, which go like that. And we're done. All right. Cool puzzle, Sanabas. I enjoyed that. The counting circles were almost just a set of givens when you thought about them hard enough, which was interesting. So it was solve the counting circles, then solve the ren bands, then solve the Sudoku, or some hybrid of there. Cool. Well, let me know how you did, and if you enjoyed this, why not leave a like, subscribe, and a kind comment below.